axis or from the back? Open them. How do we open up the presentation? This is someone else's. Let's give it there we go.
Alright, hello everyone, my name is Kyle,
I'm Abdul.
I'm Austin.
I'm Eric.
and we're going to present our new toy, PV Pinball. And the origin of this game came from the classic game of pinball that everyone enjoys. I remember being a kid, I played pinball on the machine and on the computer, the Space Cadet Pinball you can see here. It's a classic game. And we wanted to know, how can we improve it? What's good about pinball? It's intense. How can we make it more intense and more enjoyable to play? And so we looked to some other games to look at that. Another intense game, air hockey. We have player versus player goal scoring action. That's brings some of the intensity to the game. And also foosball, a soccer-based game, spinning the players, shooting balls around obstacles and into the goal. So we took some aspects from both of those and added them into pinball and created something.
So as you can see, this is the result. So similar to something like foosball, we have two sides of the board here, and each player goes on each side. And then we also have these translating objects in the middle here that will go up and down, which will block the ball, and then we have spinning objects here that just serve as spinning obstacles. And then we also have competitive play, so it's a Purdue versus IU theme is what we decided on. And so the game mechanics of this game, it's pretty simple. If you score a goal, that's 1 point on your side, and then you have obstacles in here that serve to either help you or to not help you. So these moving obstacles will either block your ball or block your opponent's ball. And then these flippers here just serve to launch the ball.
Alright, so here we have our flipper mechanisms. So when we modeled it in Creo, we made it a cam mechanism. And then we had the rod act as a slider and then the flipper as a pin. So this slider would go out and this would follow it.
This is supposed to move. I'm not sure why it's not. It's a gift, but it's that.
And then when we actually implemented in our model, we used we actually implemented in our model. We 3D printed the flipper parts and we assembled it using both nuts and bolts. And then to actually make the flipper return back when you let go of the thing, we used eye hooks. So we used one eye hook as a guide because so the bolt stays aligned when it's pushing the flipper. And then we also used another eye hook to restrain the rubber band and connect it to the flipper so it pulls it back when we're pushing the button. And then we also have spinning obstacles. We did a turbine-like shape that we modeled in Creo, and we did this using a variable section sweep to create the curved pins. And we 3D printed these spinners, and we had an area to press bearings in them so they spin freely. As you can see. And we attached it to the playing field using both nuts and bolts.
Alright, so our translating obstacles. So as Kyle showed, the white and gold block in the middle, you're translating up and down using a gear, and that's connected to a servo. So we basically want a mechanism that moves the blocks up and down on each side, alternating, moving them up and down basically, so that it would create an obstruction in the path. And we used an Arduino to code this system, and the mechanism itself was a gear and rack, which was 3D printed. And the electronic system we used for Arduino, we used the Mega 2560. We used this because our Arduino is broken and this is what's available to us, but coincidentally, we want to use an external power source as well instead of a battery because it'd be easier to use an external power source than replacing a battery every so often. So we powered it using the wall socket, and the servo motor was looped using the Arduino IDE, and it changes the angle of a range of 80 degrees. So it goes 80 degrees one direction and comes back, with a delay of 25 milliseconds per angle.
Alright. And our final prototype is up here on the screen, but also right here it works. It looks like we can plug it in back here. Might be hard to see from the side because it has some walls on it, but everyone can come up and look afterwards as well and see it moving.
This is a chart.
It might not fit. It's not gonna fit. Well, we can just,
We can plug it in elsewhere later then. Any questions about the design or fabrication process? Yes?
What would you guys say was the hardest part about assembling all of this?
Definitely the flipper mechanisms, the tolerancing and placing these two pieces on either side of the board and then having them rotate just from something else pushing against it like a cam mechanism. They got stuck a lot initially. We had to work around that.
And as you can see from our image at the bottom, so we had to do a lot of additional attachments. We had to add an eye bolt and everything, make sure that our pushing, the bolt that we use to push it stays in like a straight, so it stays straight instead of falling down. That was the problem that we had. The bolt would fall down through the hole that we made for it to move.
Anything else? Yes?
Is there like some reasons for making for the designing the spinning obstacle on this side?
The spinning ones?
Yeah. Is there like some reason like
Just
for
to-
making like a
Oh, curve?
the curve?
No, it was purely aesthetic.
Alright.
What would you change if you do again? Any parts of the design?
One thing is we'd probably make the slope a little steeper. It does get stuck sometimes, but kind of, it's a very
yes.
small slope.
Yeah, we wanted to make it as short as possible, with still being able to play, but I think we kind of underestimated how steep we actually need to make the slope, so in the future we'd probably change that.
Anything else? That's all?
Oh, maybe I missed something. So how did you actually execute those obstacles, spinning obstacles? So are they directly driven by
They're not
or-
electronically controlled in any way. They just get hit by the ball in action and spin.
Guess you can generate just that.